Hello, folks. You probably saw some of my intro. Hi, I'm Pradyun Gedam. I'm one of the members of Bloomberg's Python infrastructure team, and I'm going to talk about Python packaging and Bloomberg. My intent with this talk is to provide a window into how an institution like Bloomberg does Python packaging. With my packaging tooling maintainer hat on, this sort of visibility is kind of difficult to get, especially with institutions that use and rely on these ecosystems, but don't really tell us how and what they're doing with it. So my hope is, let's demystify some of that. Oop. It worked. I should do a more relevant introduction for this group here. Hi, I'm Pradyun SG from the internet. Most of my profile pictures are that blue logo in the corner. You might know me from one of the many open source things I'm involved in. Possibly because it's something I wrote, possibly because it's something I've created, or maintained rather, or it's something I've broken in some visible fashion. The next thing I should cover is Bloomberg. You're probably aware of Bloomberg News, but that isn't the main product of the company. That would be the Bloomberg Terminal, which is software that delivers a diverse array of information, news, analytics to facilitate financial decision-making. More seriously, it's, as you can hopefully see from the picture, it's a bunch of independent functions, we like to call them. They're essentially products. And the terminal is built of these many applications. Email is one of these functions. News has its own group of functions. Equities have their own group. Really, it's thousands of mostly independent applications. They provide market data, messaging, just news, analytics, all sorts of information. And it's an information aggregator to help you make financial decisions and then act on them. There's a numbers slide. It's a company that's older than me by quite a margin. It has lots of users. And there's a sizable software engineering department within the company as well. And the company is increasingly contributing back to the commons, so open source software, web standards, academic research, and more. OK, that's the preamble, and that's Bloomberg. What about Python at Bloomberg? Well, depending on what metric you choose to use, it's the most popular language in the company. C++ ends up #1 for certain other metrics. Regardless of which language comes first in that context, there's tens of thousands of Python applications at Bloomberg powering some business function. Some of these moved to Python 3.12 on the same day as the release, which I think is really neat. Serving as the foundation for all of this tooling, or all of this software, is the tooling that my team maintains as Python infrastructure. This includes the Python interpreter and other infrastructure pieces. Relevant to this talk, the Python packaging tooling. So what is the packaging story like? Well, at a high level, we use the same baseline tooling as the rest of the ecosystem. So pip, virtual environments, and all that. They're a significant part of our development workflows, and we work to stay compatible with them. This means being able to use the same standard pip installable package workflows and not locking people out of other workflows, because, well, the entire ecosystem uses this as a baseline. Even conda packages are built using these tools. And they provide a developer experience that people know. Enabling rapid deployments is a big piece of what makes this a good development experience for people. It also helps that business logic can evolve quickly, which it can. It sometimes needs to. There's also not really an option of not handling extension modules. The entire scientific Python ecosystem depends on it, and hey, we're a data company. And, well, we use C++ extensively, so it's also a non-option for that reason. Finally, we treat libraries distinctly from applications, which is maybe atypical in the Python ecosystem, but maybe not. I'm going to spend the rest of the talk discussing this by starting with the simpler piece, libraries. So in a massive surprise to absolutely nobody, we write libraries that are reusable internally. This code for Python takes the form of regular pip installable packages with all the behaviors that come with that. These libraries are shared internally on a PyPI-style package index so that you can pip install them. And that package index has additional validation to, well, as part of the publishing pipeline to ensure that you're not doing something subtly wrong or non-compliant with the upstream standards. And the builds for these packages, they take place in a controlled build environment. That's ensuring that we're not building with like the wrong stuff, have all the right build dependencies, and the relevant compiler and all that stuff. The other piece is the third-party libraries. I can't move away from the laptop because I need to keep tapping. This is open source libraries. These are pulled in from, well, wherever the code needs to come in with a curation step. I'm one too far. Which we also have the ability to pull these packages and build them with patches if needs be. These publish in the same place as first-party code, which goes a long way in reducing workflow friction. So an application can use first-party and third-party libraries together, and first-party libraries can depend on third-party stuff. And for libraries, that's it. There isn't really much else needed because most of the work of packaging libraries is in building them correctly, and that's build environment stuff, and creating a good developer experience around all of this so that you don't have busy work or paper cuts in the process. The technical solutions, let's call them that, what's the phrasing I want to go with? The technical solutions for how to package code is, well, they exist already. And ensuring that things are safe to use and where they're going to end up being used and all the validations for that, that's a tractable problem that's tractable to solve. A big piece of why is because the Python packaging ecosystem as a whole has a polished story focused at libraries and how to distribute them. That same level of polish does not exist for applications, which is the rest of this talk. For starters, the foundational packaging tooling doesn't really have a concept of applications. And honestly, it's non-trivial to even get everyone to agree on a single definition for what an application means. Is it just your code? Does it have a shape? Does it include dependencies? Does it include the interpreter? Does it include the OS? Do you ship hardware? Well, it depends. Yeah, so on the Python packaging user guide, yes, that's a thing, packaging.python.org, there's the super helpful overview. It walks through the various options that you have for what packaging an application in Python looks like. It's got nice diagrams even, which we'll hopefully see as I scroll past this because, yeah, there we go. And this long page walks through all the options you have or approaches that you can take for packaging a Python application. This document is based on a talk by Mahmoud Hashimi. I'm sorry if I butchered that name. At PyBay 2017, the Python packaging gradient. He also contributed the original draft for this page to packaging.python.org, which is what's shown in this GIF. Yeah, so from that page, I really like this one image. Specifically, I like how it visualizes the gradient from just the code all the way up to let's ship hardware that you plug into a wall socket. So for that earlier slide, this page is basically saying all of the above is the right answer. And each of the layers in this diagram are solving a different problem or a different set of problems. And for the details on what those problems are, go watch that talk or like read the page that I took this from. I'm not going to repeat all of that information here. But this is useful context setting for where Bloomberg draws the line on these. So on that gradient of just the .py files to ship literal hardware, we ended up with two approaches. One, which is maybe not surprising to many people here, cloud-native build packs. It's a standardized mechanism for building container images from source code. And the packaging step there is build the image for the container with a build pack that pulls things in. These images can then run anywhere that you can run a container. And honestly, that's the packaging step there. Run the container build. Then we have shrink wrap. Haha, that's a new word for some of you. It generates a self-contained application bundle that you can run anywhere that you could run Python. It's similar to freezers in this image, but let's talk about that. What do I mean by self-contained in this context? Well, it's mainly to do a distinction with what Bloomberg used to do in the past, which is a system-wide deployment of all the applications that will run on a machine where everything that runs on that machine needed to deploy together and use the exact same dependencies. As you can imagine, it doesn't help with rapid deployments, and it requires additional tooling to ensure that you're doing the right thing, developing against the right dependencies, changing dependencies doesn't break stuff, all of that good stuff. So what does shrink wrap do? Well, it takes a ship your interpreter approach, which, well, ships application code, dependencies, Python code, the interpreter itself. And this is combined with an additional magic layer of doing many Linux-like thing. For those not familiar with many Linux, it's the Python packaging standard for taking a wheel and running it on an arbitrary Linux machine based on some guarantees of if you have this glibc version, looking at all the things that are out there in the world, yeah, you probably have these system libraries. Everything else, let's pull those in. We do something similar. So including all the runtime SO files or runtime libraries into the application bundle. These are shared libraries that aren't going to be provided by the OS. So this makes it possible to run it wherever you have that baseline OS. We have 3 different Unix environments in the company, and shrink-wrap helps support all of them cleanly. Well, that's part of why it exists. With the other part being enabling projects to evolve independently, which kind of important. That's the fact that we're shipping the interpreter in these application bundles also means we can have the interpreter evolve on one application before another, and they can all incrementally evolve. That's part of how we ended up with Python 3.12 running on day 1, aside from all the work that you need to do to actually trust that the code that you're running in production is something you can rely on. So doing it safely. And something that is hopefully not surprising is shrink-wrap is built on top of open source software, standing on the shoulders of giants and all that good stuff. Virtual environments and pip. They're the foundational pieces, as I mentioned earlier. They're the primary way for fetching libraries and handling stuff, and providing isolation from the global Python environment that comes with your OS and stuff like that. ResolveLib, it's a dependency resolution library. It helps with solving a few tricky situations when mixing libraries that come from different sources, or if multiple options are available during the build, which can and does happen. PyElf tools is used to inspect shared object files and figure out what the dependency graph looks like. I see a few people smiling at that. And PatchElf is how we modify these shared libraries so that we can actually get them to be picked up from the bundle rather than somewhere else on the machine. And for each of these projects, one or more of the maintainers of it work at Bloomberg, which goes towards ensuring that these projects are well supported. Which leads me nicely to the fact that Bloomberg does support the foundations it's building upon. As a visionary sponsor for the Python Software Foundation, which is their highest tier, and by providing funding for full-time roles that the Python Software Foundation has invested in to support the packaging tooling, as well as CPython itself, so the main implementation of Python. We're also fairly involved in the general Python ecosystem, with engineers employed by Bloomberg serving on the Python Steering Council, as CPython core devs, maintaining Python's packaging tooling, and contributing to, well, lots of projects, but here I have Jupyter written down. On that slightly upbeat note, I'm going to say thank you. I do have some time for questions.
Thank you, Pradyun. Let's see if there are any questions here. There is one.
Thank you for the talk, Pradyun. So when you say you're using PyElf tools and PatchElf, are you delocating the shared objects into basically like a...
Yes.
Got it. Cool.
Hi, yeah, thanks again for the talk. You said that you hosted first-party libraries on your packaging infrastructure, and I was wondering if you had tooling to automatically roll dependencies whenever those get updated in client applications.
Yes.
Is that available?
No.
Thanks.
In part because it's fairly coupled with how we do things internally in our internal build and deployment systems, so that we can detect, oh, this updated, let's ping this and then ping this and tell the engineers that, hey, you have a change to make, that, and here's the patch and all that stuff.
You mentioned using PatchElf to change the RPath or run path entries. Do you do anything to deal with hard-coded paths in the text section of the binary as well?
In the text section of the binary, I think so. I don't remember the details there, but I think so. I think there's a few cases where you can't completely isolate from the system, where you're like, okay, this now needs to be on the system. Some of them are like hard-coded paths, for example, which in theory you could also patch on the library. So there's a few ways to do this. I don't know the details of this, in all honesty. So, yeah.
Okay, thank you.
You showed how big Bloomberg is, and you're very active in the Python ecosystem. There's bit maintainers, virtual inf maintainers. How much influence would you say that Bloomberg has on the Python ecosystem? So how often does stuff happen because it makes sense for Bloomberg and maybe not for the broader ecosystem?
I don't think we try to do things on the basis of it makes sense for us and therefore it should happen. In part because often we're not the only stakeholder on the table. Like, I'm a pip maintainer. I'm also a Bloomberg employee. So it doesn't mean that every change that happens in pip has to be a thing that Bloomberg approves of, or even that has to happen only because Bloomberg benefits from it. I think we understand how that relationship works, and that it's a give and take. And sometimes things will happen where we need to make a change because upstream did a thing. Sometimes we can talk to upstream and be like, hey, can we actually do it this way and collaborate on this rather than. So I think it's a healthy, I think the best way that I would phrase it is we understand how this works. So it's not a case of we're involved and therefore we will get the say, right? It's we're involved. Let us be involved.
Shrink wrap looks great, but it talks to Linux systems only. Have you given any thoughts to the really portable shrink wrap thing where I can say, build it for Mac and Windows and Linux at the same time? Which is the problem we have all the time, the TensorFlow people. You got a researcher, it's got Python script with embedded C, and it builds on the Linux Forge farm, and then they run it on a Mac.
I was navigating while you were saying that, because this page actually goes into some of the solutions that exist on that spectrum. Shrink wrap doesn't really fit the general need of being cross-platform, in part because we don't have that need. But there are solutions that do. So there's ways to take a Python application and make it into an executable that does things appropriately on Windows, Mac OS, and Linux. And even if you want to go down the route of building installers for them, that also exists.
You mentioned at the beginning briefly that you're using a PyPy style index, but that's is that something you built yourself? Is there parts of this that are open source? What exactly is that?
There's parts of it that we've built ourselves, including sort of the interface that we have with the outer world, so that we're not pulling in arbitrary stuff that we don't trust. There's bits of it that are reusable pieces. I don't know how many of those are open source, in part because I am not responsible for them.
Hi, thanks for your talk. For third-party libraries, you said you have like a curated subset available. What's the process and the criteria you use in that curation?
We essentially have a layer between us and the internet that controls what comes in. And depending on the process, it's either automated or a human has looked at it and gone, yeah, that looks fine. It depends on how much we trust the upstream authors as well as the source that we're pulling it from.
Are you taking into account things like security and vulnerabilities in that curation?
I don't know.
Okay.
We have one online question. Nice. Sounds a lot like what Conda is doing. Have you been investigating it? Any specific reason why it didn't fit?
Good question. One part of the answer is this is what they were doing already before I joined. The other part is, I think one of the things that Conda does is it requires everything that gets pulled into the ecosystem to be built in their specific format. And it needs to all be binaries, which is not true for the broader Python world at large. So that is in part why Conda Forge exists, to essentially be that translation layer. We could build all of that infrastructure internally or rely on Conda Forge, or rely on what we already have with the guarantees of our baseline OS and our build infrastructure. And given that we have the reliability of our build infrastructure, we use that and lean into controlling the build environment ourselves, rather than doing it in Conda's build it once on a well-known thing and ship binaries for it.
Okay, thank you so much. I think we're out of time, so let's thank Pradyun again. Thank you so much.
Thank you, folks.